Hallo Freunde, es ist die letzte Tag, no, das letzten Tag der April? No, von April. Alright, German's failing me. It's the last day of April. Um, we have more red items than we can get through in, I don't know, some rustic phrase of time. Today we're going to be looking again at the tensor T and supporting types. So that would be span nd as it's currently proposed and friends. And yeah, let's see what we can do. Oh, even more people in the room now. Amazing. All right, so yeah, Tanner, I guess take it away.
All right, so we reviewed a lot of this a couple weeks ago, and there's been a few changes since. So I'll kind of skim over the ones that we were generally okay with, calling out the minor changes and context that's been presented since then, and then we'll get to the parts that we that had more substantial changes. So as per last time, working with tensors, you need to be able to work with larger than 2.14 billion indices. So that necessitates us exposing a new type, native index and native range. These are essentially identical to what they were before, with the addition of the things that API review asked to be added. For example, the constructor that takes index directly to parity the implicit conversion, the toIndex API, although we never landed on whether that should always do a checked or unchecked conversion, or how users would get the other one via named API, since that's not a concept we've had to consider yet before. My intuition would be that we would have toIndex and toIndex checked, as that more mirrors the default behavior for the explicit casting. If you're not in a check context, which is the default, then you don't throw. So make the one that does the checking explicit by including it in the name, just like it is in the operator name. So if we were to expose both, they would be toIndex and toIndex checked. But otherwise, native index and native range haven't changed. They remain as is, and the language was generally fine with the shape here. There's going to be another meeting on the 23rd where they're going to confirm whether the implicit casts are fine. They should be fine. It just minorly plays into future language support, as they'll likely or potentially have some kind of language support for native index, and therefore a language defined conversion that is that ultimately has a higher precedence than any user defined conversion could.
So I'll start by saying I think the concept is fine. I'm not in love with the name of the type or the types. Native, my initial reaction isn't, oh, this is enint. My initial thing is, oh, this has something to do with interop or non-managed code. Also, when we have types or methods that are distinguished by referring to some primitive, we usually refer to their system.name, so int32 blah or double blah. And so I would expect here this would be intputter index or something like that. Native index just doesn't seem like the right fit, because it's really describing the type that's being passed to the constructor.
Yeah. Well, by convention, the name would be index putter if we were to make it consistent. But
well, why?
Because that's the suffix convention we used for other types like integer. You've got int number, and for the pointer width, it's PTR.
Right, no, that's what I'm saying. It'd be like int ptr index. Like we'd have int32 index, int putter index. Because the thing is an index and it's a specialization of that, and we generally put specializations as prefixes. And it just so happened that the built-in, the initial one has the int32 as an implicit thing. But if we were to ever
I'm
add
not
support,
a huge.
sorry, I was gonna say if we were to add support for, long, it would be uint64 index, and if we were to add support for double, it would be double index.
I would rather hope that if we did something like add a 64-bit index, we would consider calling it something like index 64 instead.
Is what you're saying, Tanner, that it's not an int anymore, it's an index, and so we're replacing int with index, and then you keep PTR.
Yeah,
Because-
but I also don't like the concept. So everyone gets confused about the name INTPTR. There's a lot of people that think that it strictly means pointers, and therefore it also means interop and things like that. There correspondingly, when we went and there's a few cases where we decided to expose APIs. So we've got APIs like from int32, and the convention was to use the system name. When inint came out, we had a discussion over whether that should be from int pointer or whether we should disambiguate there because it's confusing. And we had opted to say because INTPTR had been so pervasive throughout various parts of the ecosystem and what people assumed it meant, we ended up naming some of those APIs from capital N, capital I, lowercase nt, so inint. Specifically to avoid the problems of people confusing what is a native integer versus what is a potentially an opaque handle. And so that's kind of why the name here was native index, because it's explicitly spelling out the name that follows the terminology of this is a native sized thing.
Yeah, I still look at it and think it's about interop, which is exactly what we don't want it to be.
Honestly, when I pulled up the proposal, that was the first thing that popped into my mind as well. It was Steven. It was that, why do we need this for interop? Like, that seems weird.
In a way, it largely is for interop. It's only ever going to be used with unmanaged memory.
No, it'll be used
or
in tensor.
Which is an opaque abstraction over memory in general, which could therefore be unmanaged.
Sure, but that is just because you're using tensor doesn't mean you're doing interop. And so having this show up in the public surface area of tensor, this isn't about interop. It's about indexing into an arbitrarily, into a longer, something possibly longer than what fits in int32. So we're basically saying, all right, we need an index that is possibly larger than int32.
Right, and the only case that applies is unmanaged memory.
Okay, but that's neither here nor there. It's still the managed surface area is taking this thing, and that also wouldn't necessarily be the case if we allowed you to index into a tensor as a flat representation, for example, then it would still apply with multidimensional arrays.
I almost don't like either. I don't like native, and I don't like PTR.
So do we need this to be inint? Could we make it be long? Could we just say it's index 64?
That's going to hurt the 32-bit case if people use it for any type of 32-bit operation for any reason.
And when we move to 120 computers.
Yeah, well, Moving to 128-bit computers is unlikely to ever happen just because physics. You can't put that much memory on a single machine and fit it into even a warehouse. We just can't make things that small.
We used to say that about like a kilobyte.
Yeah, but there's
Yeah,
a
yeah.
huge difference between 65,000 and well over 18 quintillion.
Yeah. Yes, at some point you get the like you can't even put this many atoms in a warehouse. So
Yeah.
I'm just yeah, it's just a thought off the top of my head because I feel like index 64 seems like an easier, less contentious name, but we shouldn't do it if it's not actually 64-bit on ARM32. And if we decide ARM32 is a minority case, because I think that's the only 32-bit we support, then index 64 seems like it would solve problems.
We don't support Windows 32-bit anymore?
Do we?
No? I don't know.
We support Windows on Windows, but Windows 11 itself doesn't support a purely 32-bit operating system, so you're only running a 32-bit app on a 64-bit system in those cases. But people still may be using 32-bit apps for various reasons, and
How quaint.
Is there any other possible names besides native or PTR?
Just an N prefix.
Yeah, no, it doesn't seem great either, but
We did in float, right?
yep, we did in float,
oh,
In interrupt.
which is specifically in the interop services namespace.
Yeah. I mean, it kind of depends, I think, on our view of the type, right? So, as I said in chat, I think you can make some consistency arguments, but ultimately the problem that I have with that is that they're all based on naming that we don't like. And I mean, it also depends on how we see the future of InPTR, I guess, because it was originally conceived as an interrupt type, which is why the name, PTR was all over the place. If we just think of use cases where people just want, effectively a number that varies based on address space, then I think it's a different kind of situation, right? In which case maybe just the N prefix is good enough.
Yeah, I would personally prefer just in index instead of something like int pointer index.
I know
But
we haven't
N
talked about
just
this
means
yet.
native.
I think it's I realize that shows up as a lowercase thing with nint, but in the subsequent discussion we're going to have around span nd, like the n as a prefix and as a suffix ends up meaning two completely different things. That seems not great to me either.
Yeah, well,
But
and that's why I said native index, because our convention is expand unless there's a special reason not to, and the N stands for native.
Then it should have been native int index. If that's really like just having native without the int after it, I think is problematic in my mind.
Even though we're saying that you've got native, you've got int, and you've got native int, and so therefore you've got index and native index.
It's not a native index though. It's an index.
It is.
No, it's not. It's an index using a native integer sized value.
Which is
There's no
a
such thing
native
as a native.
index.
There's no such thing as a native index.
Yes, there is. I would vehemently disagree with that statement, because all native means is that it is the size of the system. You can index into an array using an index, and if it is the size of the system for indexing, it is therefore a native index.
You index into the array using a native sized integer.
Which
It's
is
such an overload.
Index is the concept. It's and so there's saying that it's a native index. I don't think, to me, that doesn't make any sense.
Makes perfect sense to me. And if we called it native int index, I would have expected index to have been called int index or int32 index.
And it would have,
So
I
we
think,
didn't do that.
it would have if we expected there to ever be more than one, and we didn't at the time. But if
So
we
that's
needed to be
actually.
sorry, go
Oh,
ahead.
sorry. Question though, because there's a suggestion that this could have been long earlier, but that would hurt 32-bit perf. If we saw this coming, would have we made index use enint originally? Like, would have there been any downside? Like, I realize we can't do that now.
I think we either we would have made it use enint, or we would have named it int32 index.
The n could still be the same n in span nd, right? Like span nd, the n is just, it can be any number of dimensions, right? I'm assuming that's what nd stands for. Where here it's n int, meaning it could be, it varies, right? It's not a solid number. It just so happens there's only two of them. It's 32 or 64, but it doesn't have to be native.
Well, if it was the same thing, then I'd expect this to be any number of dimensions in the index. It would be an n-dimensional index.
Well, it's an index that's, and there's multiple different sizes it could be, like that.
Yeah, but that's not what it means in span nd. It
means there's any number of dimensions. Right.
So I would expect
n before. Oh,
so I would expect index to be any number of dimensions. That I could index into a span nd using an n-dimensional index.
Yeah. It's an n-sized index.
Right. Like n bits. Like if it was really the same, I'd expect it to be like nd index. But like, obviously
right,
we're not saying it is.
Yeah. It does feel like n index is a more palatable name than anything with pointer and anything with native. But I get the reasons not to use it.
I don't know. Like, to me, it's also a function of like which audience sees it, right?
Anybody doing tensor stuff's gonna see it, right?
No, I
Anyone
meant
doing
more
system
like
dot in the current name.
Or system dot, yeah.
Well, that's another part of the discussion that we were going to get to next, which was there's basically 3, maybe 4 places that it could go. It could go in system directly next to index because that's where index, range, and span live. So it makes sense to put a another type that's used for things like system.array as well, or other concepts next to the existing types. The other potential places would be system buffers, a new namespace system memory, which matches the NuGet package name, and or say that it's hidden off in system numerics tensors, and people are likely going to use it for more than tensors anyways, which is, so I don't think that last one is good. But I think if we're concerned about people seeing it, then putting it in something like system memory or system buffers would be a good alternative. And maybe if it's in system memory, people will understand the term native better because the term native doesn't necessarily mean interop. It means it applies to working with the native address space of the system, which can apply to both managed and unmanaged code.
Just taking words you said, I can also throw out that we add the non-specific qualifier address index. In the YouTube chat, we're having the what do they call it in C discussion, which is, depending on your camp, either size T or pitterdiff T. So C doesn't really help us with naming here, but
well, there's size T and SS size T. Pointer diff T is different from the signed size T. But they also have inputter of T and uinputter of T.
Yeah, but the CPP reference being the All Things Bible, they claim that pitterdiff is used for array indexing if negative values are possible. So that's why I threw pitterdiff in the mix. Because we sort of have, with the hat, we sort of have negative indexes.
So clearly, size underscore t index. All right, solved. No.
Yeah, I mean, I don't know that address index helps explain that it's not 32-bit, but if we're just having trouble with the word native, then that is another thing for people to think about.
Memory index. If we put it exclusively in system numerics tensors, we could call it tensor index, although people are going to use it for things other than tensors. And tensor index might be confusing because a tensor index is technically many native indexes.
Yes, I didn't do a bulk replace. I'm just putting it here for people to see. Is this a shape that people don't hate?
So we'd have memory index and memory range.
That would be the pairing if we go with it.
I mean, then I think it has to deal with like the memory type almost, the system memory. And do we know we want to move it into system buffers? Like, have we decided that?
No, I just threw it up there as a, like, maybe if it's out of system, your brain thinks differently. I'm just letting people visualize things.
Like, if it really is very similar to index, which it seems to be, right? Like, I think putting it in the same namespace makes sense. And then, like, same for the range version of this.
And then I still prefer native, even just because it fits even with how the language talks about it and how the runtime spec talks about it, how BCL docs talk about the term inint and native. I know people here got the initial grasp of this might have to do with interop, but that's not really how we discuss the term native in terms of our actual docs.
It's not how we discuss it when it's suffixed with int. It is how we talk about when it's just the word native.
Yeah, in .NET, it's the opposite of managed, right? Like,
no, unmanaged is the opposite of managed.
well,
Native is not the same as unmanaged.
Yeah, but if you go back to the conventions from like .NET Framework 1 and 2, native, like you put all your p invokes in a type called native methods. Like native means OS and not .NET in 20 years of history of .NET.
To be honest, like this is also not a discussion where correctness matters. What matters is what most people use the term for, and we know that when people say native, they mean native development. Then they mean native code. They mean unmanaged. They all use these terms synonymously. So, like in that sense, even if you're technically correct, Tanner, I don't think it makes a difference. Like people see this and they come to conclusions. And the fact that we can't agree in this meeting, I think it's kind of, to me, indicative that the term native by itself is not a good choice for this type. I think, to me, N would be more palatable because, you know, in the same way that we use the keyword, you know, you think of this as a term combined with other terms. And, you know, I mean, N int index would also be okay, I think. It's just very verbose. But yeah, I don't know. Yeah, I guess int index is not too bad, actually.
Yeah.
I don't think we have any public APIs with init, right? I mean, obviously that's the language.
No, we use inputter.
Yeah.
We use the system.name for all the primitive types.
Yeah. I think we can go ahead, you know, nobody really liked index pitter, but I'll say seeing it written out here, it feels like it's a pointer to an index. That it's index star. And so I think even if for some reason we think that would be the most aligned naming, I think it's a bad name. So I'm just going to erase it off my screen.
Yeah. I mean, I understand the desire for consistency. I'm just, I think in PDR index makes the most sense for people that are experienced in .NET. I'm not sure if you're coming from Python and you try to make some C# with tensors work for you. I'm not sure that name is a makes you feel warm and fuzzy. But in fairness, I'm not sure that an int index or an index does anything better for you there.
If we go with the memory, like what else could we use this type for, right? Like memory index doesn't sound terrible. Memory range kind of sounded bad right away, but if that's really what it is, it's like, here's a range of memory. Like, would we imagine APIs that would take like compare? That would take the memory range, right? To compare.
Well, except it's not necessarily fixed offset ranges. It's you could have a range from 5 from the beginning to 5 from the end, but it doesn't specify what the end is. So it has to be done in the context of something that has bounds.
Right. It's not actually a memory range of like
Right.
from
It's
this
not
address
A
to this
B.
address. Right.
Given we also have a
Well,
range type, right, that takes index. So now the question is, if you want to have one that is int baked, now how would you call that one then? Memory range?
Well, that's the next part of this.
Right. That would be whatever we replace native with here, we would replace native with here.
Yeah.
Well, it's worth noting that while system.range cannot represent an arbitrary range and actually needs the context to compute a valid address, memory range does not, because it can represent higher addressable space of the computer. So lacking context, you can always safely, and I say safely just in terms of like it's a valid computation here, assume that it's based off of 0, and therefore it is, if you do hat 5, it's 5 from init.max value, and that's the entire address space range. So you never have a potential ambiguity there.
I think that the same argument can be made for int.max value, because you're still working within the confines of whatever the data type allows.
Right, but that doesn't work, because if you have an allocation that's more than 2.14 billion elements, you can still use an index where the hat 5 represents from the end length, which might be more than 2.14 billion.
Sure.
Well, that would just mean that the go resolve yourself would need to take in an inint and produce an inint. The problem would be it couldn't store an offset from the beginning that was more than 2.4 billion away.
I'm also not sure how that matters for the naming.
Well, I think it sounded to me like there was an argument that we didn't need a second range type, that the current one would do it, but it doesn't work if you need to be from the beginning or from the end more than int.max value.
Well, I think it also depends on how you want language semantics to work, right? I would expect if we have these data types, you kind of want the hat and the ... to work, right? No?
Right, but on range, we have get offset and length. The range as it's stored, if you never needed to be more than int.max value from the left or right of the thing, then we would just overload get offset and length to take an inint length and produce inint offset and length. But that means you couldn't store a relative index bigger than index can hold.
Yeah, I get that. All I'm saying is that even if you could, I don't know why you would get away with not having a range type if you want the ... in C# to bind to some type, right? Like, don't you need a type in order to have sane semantics so that the language has something to bind against?
Yeah, what I was saying was just that that native range doesn't necessarily have an ambiguity with context, because it can represent the entire address space of the computer. So even without context, it can always represent all memory locations. Whereas system.range cannot, because it's potentially smaller than the actual address space. So there's always some range it can't represent without the context.
Sure. I think, but going back now, like, so where are we leading here?
For me, my favorites in order would be native index, in index, then memory index or address index. I don't like inputter index. Wide index just seems very inconsistent with the framework design guideline naming rules.
I'm very much against native index. If we decided to use nint index, then I think we have to be prepared to use nint in future APIs instead of intputter. And I'm not sure we're in the position to do that.
We've already done that.
Not in places where we already we use inputter in a bunch of places when we read intputter from something. We use inputter, not nint.
In the name, Tanner, not whether we use the keyword or not in the signature.
No. When we were discussing things like the as int32 and related APIs for things like vector, we had the discussion of, and I had initially proposed this should be as int ptr, and API review said no, I don't like that, and told me to change it to as inint, specifically to disambiguate the fact that it wasn't in that it was related to native integers rather than intputters.
That seems like a weird call on our part, given that every other place where we do things like read intputter.
Right, and that might have been because this was fresh when inint came out, and there was still a lot of belief that inint and intputter should be viewed as different concepts and types.
I think this was still going to
API
behave
review
differently, right?
Right, and API review has since lessened on that approach, especially since the language has actually made them true aliases of each other. But it was a variance that that API review made at one point.
Yeah, I think now that they're synonyms, it should be the same as every other place we have synonyms. So we don't say int in APIs, we say int32. We don't say float in APIs, we say single. It feels strange, other than this one-off that we historically, with 2020 hindsight, made a mistake. I don't know why we doubled down on that and say, well, actually going to use nint instead of inputter, unless we're signing up to do that forevermore.
More functionality, and so we want to maintain that as much as possible.
Yeah, I mean, for what it's...
Amo, just FYI, we can hear people talking in the background.
Whether that's people or the news. Yeah, looking... Oh, I can share here. As far as I can tell, this was proposed with inint and newint, but I guess for some reason... No, sorry, I'm wrong end of it. This looks like it was proposed with inint and newint, so we didn't change it along the way. I didn't watch the video just now, but it feels like maybe you tried to convince us instead of us convincing you.
I think this one was created based on another related discussion where we were discussing inint in general.
Fair enough.
But I'm fine with not continuing that forward. But I think PTR index is probably the worst out of the names there.
Yeah, I don't think it's super relevant, but I see the initial proposal as vector inputter. Steve, what do you think about in index and in range? Is that worse or better than native index and native range?
I like it better than native index, just because then it's kind of, who knows what that n means. My concern with it is we're doing this in the same breath as span nd, and if we do use n in span nd, it's a different meaning of n, and I think that is possibly also confusing.
If it helps, I vehemently hate the name span nd and want to get rid of the n and the d. So,
then sure, that helps.
Just saying, I hate that name with my favorite quote, with the fiery passion of 1,000 suns. So. So I'm just saying we're not sold on in there, in that name, so we're not necessarily saying that we would do in meaning different things in the same proposal. Now, we could end up with span-nd being the name, in which case then we do have to reconcile this issue, but we shouldn't take it as a given now that span-nd is going to be called span-nd.
Yeah, I don't have the visceral distaste for native index that like Steven does either, but I like n index more than the rest that I've seen so far.
In index is then also consistent with the name in float, and if we had the hindsight of 20 years, it's probably what we would have called inint. Just because of the hindsight around the confusion of int ptr, even if it does come from the C term int ptr.
All right, so do we want to say in index looks like it's the winning name and look at the rest of the proposal?
I think I would want it to be aligned with the other name. I would say let's discuss span-md and then see how we feel about it.
Okay.
All right, so the
Span-nd.
span-nd type. So there was lots and lots of discussions with the rest of the people that are particularly interested in this space. And the top two names that came out of it were span-nd, was the clear preference from everyone except for Steven, who put it as third. And the second one, which was quite a bit further second, but it was the clear second winner, was tensor span. So just for context as to why span-nd is the clear preference. No matter what you're going to do in this space, if you're working with tensors, you're going to have to learn what nd means, because you're going to end up reading Python samples, Julia samples, and samples from various other languages that all use the term nd, specifically because that's also what a lot of math uses. It's so pervasive that Python named their own type nd array. And one of the alternative names we discussed was actually just nd span, to mirror that. The reason span-nd ended up winning out over something like nd span was because it's then a suffix. It's consistent with presumably how we'd name alternatives of this type that did have a fixed dimension count. So span 2D, span 3D. It matches the suffix convention that we've used for things like vector 2, 3, 4, etc. Ideally, this could have just been called span, but of course that name's taken, and it can't be used here. But that's why span-nd ended up winning out, is because you're going to have to learn about this name anyways. It's not a concept you can escape. You're going to have to learn what nd means. And it fits in with the rest of the domain-specific terminology around multidimensional access and type names and things across the general computing ecosystem. Tensor span ended up being the second for a couple reasons. Primarily because this type doesn't strictly only relate to tensors. It works over multidimensional arrays as well. It works over pretty much any kind of multidimensional shaped data. And I was pretty vehemently against the name tensor span myself. Steven came up with a nuance here that made me like it a bit more, which was specifically that we could basically pivot and start talking about all multidimensional data in .NET as tensors. And therefore, we would basically we might no longer say multidimensional array. We might just say tensor to mean the same thing. In which case, you can say that a tensor span. Tensor makes sense because tensor is the thing representing multidimensional data. But those are the two names from the people that were in the discussion and gave input. SpanND was the clear winner, with tensor span as the next one. There was other names discussed like dimensional span, hyperspan, matrix span, multidimensional span, polyspan, rank span, SpanMD, span n-dimensional, and other names, and most of those got either no votes or were ranked very low on people's voting preferences.
It's for sure a span though. Like no matter what, span has to be in the name.
Yeah, I think span has to be in the name. Otherwise, we're not going to be able to help let users know that this works just like a span. It keeps the data alive. It is a view using interior pointers on modern .NET, etc.
I'm just curious, Eric, do you have an alternative name that doesn't use span?
No.
Okay.
No. It was just like, is this a span? Is kind of the first
Fair
question
enough.
that popped into my head.
Yeah.
And it's like, I mean, looking at the shape, yeah, it's a span, but it's not just a start and a length. There's one more piece of information about it, right? Is the rank.
Yeah, so two things that I don't like about the name are, one, we say do not use abbreviations and do not use acronyms that are not widely accepted. And while this may be widely accepted in the community that's doing it, I don't think that for a type that is currently proposed in system, it is widely enough accepted, especially because when this was first proposed, no one in this room understood what ND meant. We all thought you meant MD, and it was a typo. The second is, if this is a variety of span, aside from the fact that, we have things like matrix 3D, if we named it as multi-dimensional span would be the last word, not the first word. So I like ND span more than span ND. I don't like ND span because it violates the do not use acronyms rule. But I don't like it as a suffix, and I don't like it as just a pair of letters. I like hyperspan, tensor span, quasi span, proto span, polyspan. Basically a prefix.
Even though that would make it inconsistent and potentially confusing with read-only span and read-only whatever prefix span, and any fixed size types we could decide to expose in the future for performance reasons, like a span 2D.
I think that part of the reason we call it span 2D is because we can't call it 2D span, because the language rules say you can't start with a number.
Right. And so then there's a future consistency perspective to consider.
Right, but I don't think I would have a problem with the notion that we have polyspan and span 4D. It'd be like poly is poly and 4 is 4. So that wouldn't bother me. And then the read-only would be read-only polyspan, or read-only hyperspan, or whatever. Like, it's a prefix in front of a prefix, that's fine.
The other reason that I don't like the prefix concept personally is because I think it's also confusing with how people talk about things like integer spans. A lot of people say it's an integer span or a long span or things like that, and they don't say span of integers necessarily. And so when you're hearing that contextually, you might think polyspan means a span of polys, like a span of polygons, or some similar concept.
Right, but then you'd say I have an int polyspan, and so it's either you have a span of int polys or you have a int polyspan, and then you learn what polyspan is, and then you stop being confused. Again, personally, I don't think it's, I don't think that's ambiguous to me.
I don't think I like any of those other names. I don't like poly. I don't like hyper. Tensor span feels like the most, I don't know, walkable up to name. I know you can use it outside of tensors, but yeah. It's kind of like poly what, right? Hyper, do we use hyper in any other APIs?
No, and I was personally very against hyperspan because it's kind of stretching the concept to say that, at least in my opinion, of how it relates to hyperspace and things. And I expect that a typical person, especially without a math background, would be even more confused about hyperspan than they would be about anything else. Uh, Whereas span and D, someone might question it, but as soon as they read the doc for it or they're told it's an n-dimensional span, they'll go, "Oh, I've got it," and that's all it's going to take. Most of the other names, if you try and describe it to someone, it's going to take it's going to be a slightly iterative effort to make that well understood.
And even tensor span, it's like, okay, now you need to know what a tensor is. And the first thing you say
Right,
is
right.
tensor is a multi-dimensional collection of, yeah.
Yeah, I mean the definition of tensor on Wiki or on Wiktionary says a mathematical object describing linear relations on scalars, vectors, matrices, and other objects, which is too technical, represented by a multidimensional array. So, the Wiktionary definition says it is synonymous, or it's synonymous enough with multidimensional array. I guess not all multidimensional arrays are tensors, but all tensors are multidimensional arrays.
Would you be opposed, Jeremy, if n was still n, but the d was n dimensional? Would you still be as opposed or any opposed?
I mean, I'd still feel that the ordering was wrong.
N dimensional span?
Because you would say, oh, you need the English you would say is you need an n-dimensional span for this. You wouldn't say you need a span n-dimensional. And our types in .NET are generally named with the notion of English word order. Like, we have a linked list, not a list linked.
We also consider the consistency, and if we know that we're potentially going to have span two-dimensional in the future, then if we called it n-dimensional span, and then we had span and span two-dimensional, it's inconsistent as compared to span n-dimensional.
Right, but I think especially in numerics or that other thing you do with native instructions.
Intrinsics.
We've had places where we ended up with a name that should have started with a number and we had to move the number to the end. And so I think we all, again, that's to me, span 2D, span 4D, those are, we should have named it four-dimensional span because that's the English, but our naming rules say we can't start with a number, and like the convention is if it should start with a number, the number goes at the end. And I think that's consistent in our platform. N is not a number.
Right, but it is explicitly consistent. And they're therefore discoverable as well in relation to the other types.
Group got quiet. Right, so Tanner, you said that Mr. Tobe preferred tensor span and that you didn't like it, but if we start referring to multidimensional arrays generally as tensor, then you find it more palatable. So is it palatable enough to you?
I think I'd want to hear what everyone from API review here considers between span ND versus tensor span and what's better, just simply from the perspective that this is how it's talked about. When you talk about dimensionality of unknown size, you use the term n-dimensional. That's how Wikipedia does it. That's how educational resources does it. That's how other languages do it. So I think that it is prevalent enough, even if some people in API review didn't get it at first glance, that it is worth getting an actual vote in on whether that is the right name, and if not, then use tensor span instead.
So what was the primary objection against ND span again? Is it because n is a number and we don't start names with numbers? Was that the primary reason? Or is it just we don't understand the acronym? And then we'd have to rename n.
For ND span, it was, if I caught it correctly, it was that if we had ND span and then we made a specialized version called 3D span, we can't do that. So then the specialized version would be span 3D. And then, it's like, oh, is this too confusing to people?
That's not the end of the world. But it's good to think about.
Yeah, that one in particular, I think, is more okay than if we spelled out dimensional. And I personally still prefer ND span over tensor span. But ND span itself didn't get a lot of votes. People basically just focused on span ND or tensor span as the two names. So
one question I have is, so outside of tensor, do we really believe you use this thing?
It's likely going to be used by anything that needs to commonly work with multidimensional data and that doesn't want to specifically work with tensor concepts. So you can imagine, for example, Image Sharp could use this for more easily working with image slices. There's various libraries that are using the Microsoft Community Toolkit span 2D type already for similar reasons. And so this really just becomes a built-in version of that concept. And everyone that's using the Community Toolkit type or that's doing things like image manipulation would potentially be able to optimize their code by using this type, even though they're not working with tensors directly, like AI tensors.
I mean, I think that a span 2D might be used by something like Image Sharp, but again, my gut from having looked at this before was serious, like 100% serious, that I don't know that I'm smart enough to use this, and that means I don't think it will have prevalence. In like, people might try to figure out how to write span 2D on top of it, but I don't know that people are going to use this.
Sorry, Jared, I think, has his hand up.
That's a funny notion. Jared?
Oh, sorry. I go from other meetings where we have a hand discipline. I was just going to say, like, the at least in language design, since we moved the .NET Core, we've just pretty much ignored multidimensional arrays in every feature that we've done. And it was based on discussions with people in runtime and library saying, this is not an important scenario right now, and we can revisit if it becomes one. And we've been doing that for 7 years now. And I would say, at least in the language space, we have not gotten any type of significant feedback that like multidimensional arrays are a problem. So it's hard for me to understand how this is going to be used in anything other than tensors, given that we have like 7 years of no one really caring, or maybe there's data sources I'm not aware of. But
yeah, there's people that are using multidimensional arrays and multidimensional operations, and that's the reason the community toolkit has provided the span 2D type and why we've had requests to expose similar types in the BCL for a while now. It's definitely not prevalent. Like, it's not something the average .NET developer is going to do. But as people start working with AI, language learning models, and other things more commonly, the prevalence in some types of apps and beginner code is going to become more prevalent. It's just never going to achieve the level of criticality where you can go up to some random person and they're going to understand the type and the nuances around, like array indexing operates based on row major order, whereas you specify indices in XY order instead, which is typically column major.
I mean, the reason I asked the question is, like, it's not so much whether, whether something is, I think in principle, yes, any type can be used in any context, right? I'm more interested in, like, how likely is it? Because if the vast majority of users are using it in the context of tensors, I think tensor span is a fine name. If we think it's becoming like span, where it's an universal exchange type that is going to be used virtually everywhere people use arrays, then maybe that name would make us very unhappy, right? But I kind of agree with Jared. Based on the history of the .NET framework, it doesn't seem like, even if we, pursue more of the, the performance-oriented code in data processing, that suddenly, like, multi-dimensional arrays become this vast use case, right? I mean, we will use them more, we will optimize them more, and I think that's a good idea. I just don't think that they will show up in so many places that the name tensor span would turn out to be a bad choice. That's just my gut feel, but here's what other people think of that.
So by saying that, multi-dimensional arrays are not super common, this is basically span for multi-dimensional arrays, that we should give it like a less prominent name. Like, is that an argument for like tensor span versus span ND?
Well, it's more like, I mean, there's two arguments. One, I'm not convinced it should live in system to begin with. And then secondly, ignoring where it lives, I think the nice thing with tensor span is that, you have something you can Google, right? If you say ND, it's like, what the fuck are you going to Google? Like, I mean, you kind of have to know that it stands for n-dimensional in order for you to do something with it, right? So I think anything that has kind of more than a few letters, unless the meaning is obvious, it's beneficial, right? Now, for n index, you could make the same argument. I think that one might be a bit more nuanced because, the type is relatively simple. You can look at the type and hopefully make sense of it, versus with this one, as Jeremy said, unless you read the docs, you're not very likely to be successful using this type. So I think there is a bit of a, if we can give it a name, I think it would be preferable, right? And I think we don't really have good names, except for either very long-winded ones like n-dimensional, right, which would make read-only n-dimensional span like a mouthful, or like completely cryptic names. And I think tensor is kind of in the middle, where the name is relatively short, still something that kind of makes sense, and is something you can actually combine with other modifiers and have decent type names.
Yeah, for me, it's tensor span, vastly distant second ND span. Tied with ND span is just bang on the keyboard and whatever comes out, comes out. And somewhere at the, I guess I have to put it on the list, is span ND. Like, that's a better name to me.
If we definitely go with a tensor means n or m dimensional, like that's our word for it going forward, tensor span feels nice. It feels the best, in my opinion, I guess, if we're gonna go all in on this word.
I think just to clarify, my point wasn't that we would go and replace all documentation for C# calling them tensors. It was that we describe multidimensional arrays as a form of tensor.
Yeah.
Yeah, and my allowance there is just that, like, making sure that people are aware more readily that tensors are multidimensional arrays and multidimensional arrays are tensor, and that tensor of T is effectively the generic typed version of system.array. It's potentially how you would have described it. You know, if we actually had the generics in 1.0, you might have called it array T and made it single dimensional only, and then had a separate type specifically for the multidimensional concepts, and you could have called that tensor of T. Make it very clear that that's what this represents. It is a type representing it, and if you want to work with multidimensional data, this is what you should probably go and look at using, because it's going to give you the best experience, best perf, everything else.
What exactly is the difference between this type and tensor of T? It's literally ref struct versus class?
It's a ref struct, and therefore it tracks an interior pointer. It is not the owner of the underlying allocation. And therefore it can also track a view. So you can have a 9x9 dimensional tensor and take a 3x3 slice out of it. And therefore it has to track stride information, so it knows how much data in memory it needs to skip out of the underlying contiguous allocation to get to the next row, for example.
And calling it tensor slice. Like, if we did the don't put it in system namespace, but instead put it wherever tensor goes and call it a tensor slice, like, that would tie it more to tensor, and it wouldn't feel like people should use this outside of tensor.
Right, but people are going to use it outside of tensor. It's the main interchange type people will use for multidimensional data.
And slicing has other connotations around tensors, right? And so that might cause problems as well.
View would maybe be a better name, tensor view, but the term we use that in .NET is span. Span represents a view over another allocation.
I think that's kind of why I like tensor span, is because it's like, it's a tensor. It's like, think of span and think of tensor, and then now you put them together. It's two concepts that are existing. It's Are we sold on tensor? Like, are we sold on that name for that type, and not ND array or ND array ND or anything along those lines? Do you know what I mean? Like, why would we use one naming here and not the same naming in the class representation of this thing?
Well, the concept is that tensor of T represents a wrapper over an allocation. So it represents a type safe wrapper over an underlying memory allocation, which is not strictly managed. It's not strictly unmanaged. And span ND therefore represents a slice over the memory. And that, I mean,
we could call it memory ND or ND memory, right? To stick with span and memory.
Right, but we also have an existing memory type. And so using the term memory again there could be confusing, because memory of T works differently than span of T.
Kind of exactly. I mean, that's kind of my point, though.
Right, but if tensor is supposed to be able to track native or manage, that suggests it's going to be disposable. And memory, single-dimensional memory is not disposable. And that feels like a weird... What do you mean it got disposable when it gained a dimension?
Tensor doesn't look to be disposable.
And we'll get to that later, because I don't think it's relevant to this part of the discussion.
Well, the part that I think is relevant is the name that we're using for that thing being the same name we're using for this thing makes a lot of sense, as opposed to trying to come up with a different name for this thing. and not have the same name over there.
Yeah. For what it's
Yeah.
worth, where we talked about it being tensor view. We have used view before. Memory mapped files use view long before we had the notion of span. They have view streams and view accessors to talk about a portion of a memory mapped file.
Well, and what I was trying to explain earlier was that so span represents an abstraction over it represents an abstraction over memory that doesn't track the original allocation and therefore is a slice of it, or a view into it. And so it is the common abstraction we use for stack allocations, birefs, pointers, arrays, strings, etc. It works with all of those types because it is the common view type for them. And the concept here is that tensor of t is a particular implementation of a tensor type. Span ND is the general view type over all types of multidimensional data. That includes system.array, actual t comma, t array with the comma in the middle representing an actual multidimensional array in C#, over raw unmanaged memory, so pointers, over tensor, over the backing data structure that tensor of t wraps itself, and potentially over external libraries, tensor types or multidimensional types like TensorFlow's tensors or PyTorch's tensors, and so on. So the name span was very explicitly chosen because this is the common interchange type for multidimensional data. And then ND was leaned towards because that's the ubiquitous term in how everyone else talks about this, with tensor span coming up as a runner-up if API review was vehemently against span ND.
My point was, why are we using ND here, but we're not using ND there in tensor?
Because the name tensor itself implies ND.
I think that's a perfectly good reason to use it here. Then it implies ND, and it's
Well,
if
if
not.
ND implied tensor, well, right, like it's the other, right? Tanner's arguing for this term to be more broad than tensor.
Right, that was the reason that the group that was working on the names, the prototypes, and everything else leaned towards span ND, is because it is supposed to be broader than specifically the .NET tensor type. It applies to all forms of multidimensional data. You can argue that if .NET starts talking about tensor as the thing for multidimensional data, regardless, and it's just a general term, that using the name tensor span makes sense. But there's potential for confusion of people thinking, well, it's tensor span, therefore it only works with tensor of t, and thinking it only applies to AI and machine learning. And there's various other considerations that come out of using the name tensor that caused the general group working on this to bubble it down below span ND, which is the ubiquitous term in other languages in documentation and terminology about how you talk about memory of a particular number of dimensions. The term used is n-dimensional, and that gets frequently abbreviated as ND.
Right, but all the examples you cited used it as a prefix. You said they call it like ND array.
Yeah.
Which is why I have, in my personal ranking, ND span is massively better than span ND. I don't like ND span. I prefer a word like tensor, but I would give my support to the prefix over the suffix, even if a specialized version will be a suffix.
I think my sticking point is ND enough Does it have enough to be in the system namespace?
Well,
Again, pretend it says
ignore
buffers.
the namespace. Yeah, or memory, or something else.
Okay, that lessens the concern for sure. It's probably one of those three. Tensor span, ND span, or span ND. I don't think there's like ndim span, like emos, like that sounds terrible. I agree, fully spelling out dimension or dimensional really makes it long. I don't see anything better than those three. It's going to be a vote between those.
I actually like the term n-dimensional. Like it makes sense when you write it out, but I think it just doesn't make sense when you have it abbreviated ND. It's like there's just zero context to conclude that's what you mean.
Whether it's a prefix or a suffix?
That makes no difference to me. Like it's just different in terms of I don't know what it means.
Yeah, I think it's a thing you have to see once, or someone has to tell you once, and then it kind of sticks. But yeah, it's not like discoverable, so to speak, unless, I mean, obviously with dot comments and so forth, but just reading the name, you haven't come across it.
My own preference is still span ND, then ND span, then tensor span.
But why like? Is there anything other example in the BCL where we're like, we didn't like writing that word out, so we just abbreviated the initials in the type name?
No, guidelines in fact say seek clarity over shortness.
Yeah, because I mean, I would say there's plenty of places that I've used before where I'm like, dear God, that word sucks. I wish we could just abbreviate it. But like, it just, I don't know why. I don't know why it's like having the ND here. Like, I don't like. Just doesn't seem in line with decisions.
There's notably places where we know that it's become common enough that it becomes problematic and everyone ends up writing it abbreviated regardless, just not in code because code doesn't allow it. Like read-only span, almost anywhere someone's typing about it on .NET runtime, you're going to 90% of the time see it as RO span. And that's one of those cases where the guideline says spell it out. But realistically, that was a bad decision. And everyone would have known what RO span meant, and it would have made everyone's life a little bit better by using it. Now that one is arguably way more common than span ND ever will. So, span ND is going to make a couple people's lives happier.
Yeah, I mean,
but the general thing of spell out or not is not always correct.
I don't think RO span would have had a snowball's chance in hell of passing because we already have things like I read only list. Like read only is already spelled out.
Yeah, I agree. That seems very unlikely that we would have done RO span.
Well, I mean, given the hindsight of doing it today.
No, today I would still say I would still say spell it out.
Yeah, spell it out.
If you want it to be shorter in your code, there's a syntax for that. Boom. I mean, you have to add T's and stuff, I think, and that needs a system. But like, whatever. There's a syntax. You can do it. Like our type names are clear and approachable. We're not C. We don't just try and squish as much information into as few letters as possible.
Yeah, but there's arguably a difference between trying to squish as much information as possible and using a universally understood syntax, an abbreviation like IO. RO is on the same level of IO as being so universally understood in computing that it kind of fits in the same bucket.
That maybe like that's room for debate, but yes, IO, and you get things like URL, where most people don't know what it stands for. That's simply what it's called now. IO, people probably know it stands for input output, but maybe not. And so yes, we do have a notion of when an initialism becomes ubiquitous. I don't know that ND is that. Again, it might be within its domain, but I don't know that it's ubiquitous.
And we do notably also have all kinds of cases where we've done abbreviations in the BCL. App context, GC, URL, IO, MTA thread. You know, we've got dozens and dozens of common types where we have done this throughout the ecosystem. So we're not entirely self-consistent ourselves. It's not like this. It would be a unique case where we're saying, oh, you know, deviate from something that we've never done before. And I don't want to keep discussing and arguing about it because I don't think we're going to get on the same page about that. But I do think, you know, it's not just so cut and dry on that aspect. But it's still not clear to me whether what people's preferences from here are towards tensor span, ND span, or span ND. So I'm going to put them in chat, and if people could just give a thumbs up to their favorite one, maybe that will help give a clear disambiguation from which one is the favorite from FXDC here. So it looks pretty obvious. Tensor span is the winner here. So,
yep. For YouTube people who can't see the voting, is tensor span 4, ND span 0, span ND 1. Because I don't trust you guys to be saying things I can show on the screen or on the stream. All right, so it seems like we're going with tensor span. So if we got rid of the in, now we can pop back to in index.
Well, clearly we call this a tensor index now, right?
I don't think we can call it tensor index because that is completely different from what an actual index to a tensor is. This is the dimension. This is the dimension for a. Sorry, go ahead, Eric.
I was just going to say it's exactly the conversation we had an hour ago about the n not meaning n dimension here. So.
Right. But the statement was before we were willing to commit to putting an in here, we wanted to make sure we weren't going to use it in a different way in the same proposal. So.
Yeah.
So I'm now trying to pop back and see if anyone wants to ununify off of in index.
Yeah.
And I mean, we just had the discussion. Oh, go ahead, Tanner. Sorry.
I was going to say, just to clarify, the reason that we cannot do tensor index here is because an index into a tensor involves an index for every dimension of that tensor. And this represents a single dimensions index. So tensor index would be a very, very bad name.
Yeah, I mean, we had basically agreed contingent on what is now tensor span not having n in it, that I think it sounded like we had consensus for n index and n range earlier.
Yeah,
the question.
And we did use the name n float already.
Yeah. I'm just seeing if there's anybody who, now that we had the trip over, is like, actually I hate in index and wants to resume this. It doesn't sound like anybody's saying no, so I think we get to take that as a given now. I'll bulk update it in a minute.
The part I did think was interesting though is we just got done saying like abbreviations and acronyms are bad, and then we came back here and we were like, but this one's okay because we did this because of nint. right? I mean, that's why it's okay.
It's because there is no word in .NET that means the width of a register. The closest we have is int pitter, and we all agree PTR doesn't belong in this name. So, and if we called it register index, I'd be the only one who knew why.
Native, and we don't like native.
Steven
we
in
like-
particular hates native, but yeah.
Right.
Well,
But
I
we
mean,
like
look at all the
taking
improvements he
native
makes in
off.
managed.
You're right.
But that's what the N
I think
means, though, right? It means
Yeah, the
native
N
size.
stands for. Yeah, the N stands for native sized index.
I just don't see any other better name, I guess. Okay, I mean, I just wanted to just fully say 5 minutes ago we were saying no abbreviations, and then we came here and we made an abbreviation. But we think it's the best.
Right. All right. So anywhere that says native index, pretend it says in index. Oh wait, I can actually just like fix this. We have that technology.
And anywhere that says native range, in range.
Right. And then please tell me no one wants to use a different prefix on this one.
And then presumably that means that if we added span that uses native links, it'd be in span.
I guess.
Jared dropped
Not
off.
gonna call it native span.
I was gonna say that depends on whether we'll have language support to just be able to change span without breaking people, but
We can't change regular span. So we could do the thing to make regular span work with native length. The issue there is that it means that the default indexer needs to basically do a checked cast down to int, which means that you can throw by default in various cases. The JIT could theoretically do perf work to get around that, but that is a very expensive and potentially problematic thing. So we would very much likely have a second type to represent that. Or we just tell people use tensor span and
maybe
have one rank.
I mean again, so I mean I'm a little bit thinking the future here. If we get to the point where we think that we absolutely need to have wide addressing for span, making a second type is very expensive in the ecosystem. Making a lot of expensive work in the JIT is the benefit of a platform. One person does a lot of work and everyone benefits.
Right.
So-
So just to clarify, the issue isn't the amount of work the JIT would have to do. It's that it would necessarily, it's not pay for play. We enable it, most people's apps get slower.
Maybe on a 64-bit there would be no cast, so it would only be expensive on Win32 and ARM32. Those are frankly second-class citizens.
No. It's not about 32-bit being slower. It's that every for loop in existence is for int I equals 0. So every for loop is using integer, 32-bit integer-based indexing.
Yeah.
You now have to give in an arbitrary init without the appropriate tracking, and there's lots of places where that's not plumbed through, where you definitively know the range of the index. It means that you now have to do a checked cast to make sure that it fits within the 32-bit bounds, and that becomes more expensive.
Only on JIT32. And no, int would always...
No, on 64-bit. It's on 64-bit as well, because you're going from 64 bits down to 32 bits to do the various checking. Because there's lots of apps that won't work with actual 64-bit indexes because they've been written to assume that length, so length itself can't change from returning int.
Well, again, that's
Because
where
that's a
the
binary
language
break.
support comes in. That's the if you read this in the closed context of an int, then it has to stay an int. But that's the question really is would we be able to upgrade it and say that we made length be int, but it's int for binary compatibility or for the tight assignment. Again, this is future theoretical.
Right, and
if we ended up with another
right, and
type, I
that's
think it's in span is what we would say it is based on what we're saying today. But
Yeah.
the hope would be that there are enough language improvements that we don't need to make a new type because that was the UTF-8 string death is how many places do we have to put it? Too many, kill it. And
right, and what I was saying is that because of how people have written for loops and everything else, you can't do that in a cost-free way. You have to have cost because you're going to have the for loop that's that's 32-bit integer based comparing against an init length, but the init length is potentially too large. So if you have it return an init length, then you end up having to then you potentially have an overflow error because int32 can't actually increment up to max value. It will wrap around before then. Inversely, if you have it return int, then the underlying length could actually be init, and so you have to do a checked cast to say if this is actually larger than 2.14 billion, throw, because this loop cannot handle it. So there is literally no way to do it 100% of the time in the cost-free way. You actually have to go have everyone rewrite their code anyways.
I guess because their call context would be the for loop.
Yeah.
Fair enough. Yeah, but again, we might decide that we're okay with that and that people need to call long length is what our only better name would be. But that's a thing that we're not deciding today. But I see that people are saying our future theoreticals in span of t and read only in span of t look ugly.
We could call it span 1D of t. Make it very explicit. It's one-dimensional.
Yeah, we could. What's the difference between span and span 1D? Span's multidimensional? No. 1D uses bigger numbers. Because 1. It's a longer name. It's clearly bigger numbers. Right. See, also short. It's a shorter name than long. Yeah. Right. So, I don't think we're going to do better than these names. So with the 15 minutes left, do they have the right shape? I think the one piece of question that we have, just because we don't have enough precedence of having the types here, is what do we use for checked versus unchecked named operators?
Yeah, and the actual since the actual way you specify it in the language is by adding the checked word, in the way the actual IL name for the operators is you add the checked suffix, so op addition checked. I think the natural thing to do here would be to index checked, which also fits the terminology we used in generic math for create checked. Alongside create truncating and create saturating. There was no just create to keep it unambiguous.
Right. For big integer, the named, I think it has named operators, and they're all checked, right? We don't have, like, the unchecked operators are the ones that you, like, you have to use the casting syntax for those.
Right. And that's partially because big integer was defined before we had the ability to define both checked and unchecked, and we determined that the safer thing to do at that time was to always throw for those types, just because users didn't have any way to do it otherwise.
Right, but so our current state of affairs is all of our named conversion operators are checked.
Uh,
or at least
for
the vast majority.
Yeah, I think for our numeric types, they are. There may be conversions in other cases that don't throw from the named ones, but I think that is the more prevalent. So are you thinking then toIndex and toIndex unchecked for the named version?
Yeah, I guess. Because I don't know that when we added unchecked operators on big integer, we gave it a name.
No, we didn't.
I feel like for some reason we left that to be today's problem. But
and yeah, I think we left it partially because we didn't want to discuss it, and because most people don't use those APIs anyways, they just use the operators.
because the unchecked feels more like our other think about this patterns like unsafe. But unsafe I think is usually a prefix. And then I don't think we necessarily want unsafe to mean unchecked. I mean, unchecked is arguably unsafe, but
yeah, we generally have used the term unsafe there to mean non-deterministic behavior in similar conversion-like APIs.
Mm-hmm. Yeah, I think to me this looks like a happy pair. The only thing that's weird about it is if you use the operators, you're getting your language scope check rules, which probably mean you're unchecked, but the named versions prefer checked over unchecked. But I don't. At least to me, this feels more consistent with the types that previously had conversion operators.
Yeah. And then with the name tensor span, presumably that's going in system numerics tensors next to tensor. Are we then putting these ones next to tensor as well?
Oh,
or are we wanting it buffers or system or new namespace like system memory?
That's a good point. I don't know that it's a given that tensor span is going to go in the same namespace as tensor.
Okay.
So if the argument is, so just letting people think about things, if the argument is tensor of t is, the .NET representation of this concept or whatever, and that the tensor span is more, just the projection no matter what's ultimately backing it, though it still has to be backed by relatively linear memory. Like it won't support linked list tensor notions. Then there's an argument that says that it could live in like system buffers and be in a completely different library from tensor, unless they're all going to be in corelib, in which case the library doesn't matter. But so anyway, I just don't know that it's a given.
Corelib.
I think it belongs in system numerics tensors.
Okay.
I think it, even if we could find a different place for it that we could spin, I think the most expected place for it is in that namespace.
Fair enough. But then do we feel that
Yeah.
in index, because really in index, it depends on where we think we're going with in span.
Yeah. If we exposed an in-span, presumably that one would not be in tensors, and it would, if we said that it was esoteric enough that we didn't want in system directly, we'd put it in buffers or a new namespace like system memory.
Everyone else is getting like how incredibly hard it's going to be to talk about this type, right? If it's in span, is it in span or is it in span?
Well, you should say in the span versus in the in span. That's what the deterministic.
I mean, it's gonna be in this like I'm just listening to you all trying to parse every word, and it's amazingly hard.
Yes. Definite articles are your friend. Don't go as far as German did. We don't need that many. We just need the one. I mean, we're happy to hear another name from you, Jared. As long as it's not native index. You get flicked for that.
Listen, there are reasons why I don't name things. there are very good reasons why I'm not allowed to name things.
Right. Yeah, so if we think we're going to end up in the path where in span is a separate type, or span gets upgraded but has to talk about in index because we feel that we can only do complicated magic juju on one core type, then that means that index and in index need to be relatively global. They don't necessarily need to be in system, but they would presumably want to be in system buffers more than they would want to be in system numerics tensors.
Yeah.
So buffers, I guess, what's in buffers? I feel like it's
Buffers is kind of a grab bag of things, and there's a lot of weirdness that we put in here because of net standard and other reasons. There's also the system.buffer type, which is not the same as the system buffer's namespace. And of course, half of these live in the system memory package, which is different from the system buffers package, which both of them have things in system and both of them have things in system buffers.
Yeah. So chat has pointed out multiple times, and I haven't relayed it, that they're suggesting that maybe we're thinking about this too hard, and what we want is, instead of a different index type that's on inint, we want a generic index type that's on binary integer, unmanaged integer, etc. So I will let the meeting get derailed with that.
The proposal actually has the reason why we didn't do index of t. So if you do it over an arbitrary t, then you can no longer optimize this. So index in particular is represented today by a single int field, where indexes from the end are represented using one's complement negative values. You can do that. You can do the exact same thing if you have inint, if you've got long, if you've got int128, and you know the type in its representation. As soon as you have some type where you don't necessarily know the representation, it no longer becomes safe to do that optimization, and you need to track two fields. The same is true if you're using unsigned types and things like that. So you basically lose all of the benefit of the highly optimized type if you go with a generic one, and you don't really need a generic one because this represents an index into memory, and you're never going to have more than 2 to the power of 63 elements in a collection. You're never going to have that much memory on a single computer. If you are on a supercomputer and you have it, you are doing customized addressing and non-coherent memory access, and you can go build your own system with your own types.
Fair enough. All right, so yeah, system buffers, while being a tiny grab bag, has the advantage of it exists.
Yeah.
System memory, which would match the name of the package that contains most of the things that are in system buffers, would mean that we're introducing a new namespace. Also, it would semi-conflict with system.memory, the type. It's memory of T, so it's not actually a conflict, but it would kind of look like one. And so I don't think we'd want to invent a new system.memory namespace here. Buffers seems common enough and out of the way enough concurrently that it feels like a reasonable home to me.
Yeah, I'd prefer that. I'd prefer buffers over numerics tensors. And I think that's an acceptable place if we don't want it visible to anyone who types system dot.
All right. Does anyone object to the rehousing this type into system buffers?
And are we putting tensor span here as well?
I would leave tensor. Wait, sorry. Put which one where?
Would
You
we
say
put
tensor
tensor span in system buffers as well? Or
I-
would we say only in index and in range are in buffers and tensor span is in system numerics tensors namespace?
I'm still in favor of keeping it in system numerics tensors, keeping tensor span in system numerics tensors next to tensor and whatever else. I don't have a strong opinion on an index or in range. If we want to put it in buffers, that's fine, I think.
I assume you have a semi-strong opinion, because how do you feel about system?
Do we think everyone and their, relatives are all going to be using an index?
Like that, to me, that comes down to guessing about the future of what happens to span. When do we cave and make an index-based span?
Yeah, I imagine that even if we do make an in-index-based span, that's just the point where we add one namespace to the default global using list.
Or, I mean, we can always also say it's esoteric and leave it out for a while. And in span could live in system buffers as well.
The number of places that index and range actually show up in one's code are very small.
That's true.
In index and in range will appear more just from the perspective that the language doesn't want to have to do the implicit light up that it did with index. And there's also complications with doing that for multidimensional indexing. So things like tensor of T will explicitly use in index and in range more than other types use index and range.
One question. So sorry, I'm going to go back a section. You all, when we were talking about tensor span or whatever we end up deciding to call that, that's not going to be in core lib. That's going to be in a separate assembly.
Correct. At least for now.
Which assembly?
Right now it's system numerics tensors, which is a nupcake. What's the frown?
Because we're starting to, because like we have that other thing we're doing in the language where we're basically starting to effectively consider spans intrinsic types. And the special casing in the language, we have the stack Alex and everything like that, and we have that one change where we're trying to feed through spans through generic inference. And a lot of that was based on their kind of primitive types, and all the primitive types are pretty much in core lib. And so I'd assume we'd want all the inference work to work for tensor span or whatever this ends up calling as well. Otherwise, it would just be a complete disconnect. Primitive types that don't exist in core lib are fun, but we could probably work it.
Having the inference work would be great, especially given the problems you have with span versus read-only span versus T-array and other things today. I think it'd be slightly less problematic for tensor span because most people aren't going to have multidimensional.
It's kind of two parts. There's two parts to the work we're doing in the language. One is we're fixing inference so that it actually works the way that I'm sure 99% of people think it already works. So that you can infer T's from the elements like you can for arrays today, but you can't for spans. The other part is we're trying to the problems we've had where you all have so many implicit conversions now that it's kind of an unwieldable matrix in a couple of areas where we want to take them over as primitive types where we take over their conversions so that we can get the fits into overload resolution that we all want. But that basically means things like you guys can write as many implicit conversions as you want on span, and we're going to ignore them and just have the ones that we have in the language. That's how int works. That's how everything else works. It's just mimicking what you have there in the language. I'm not sure that there's any case where we do that for types that exist outside of core lib. So it's a little ganky, but we can talk about it.
Yeah. Well, and there's nothing preventing us from putting tensor span in core lib under the system numerics tensors namespace.
Mm-hmm.
We moved vectors and other types into core lib because that was the appropriate thing to do with them to get JIT optimizations and the like. And it's entirely possible that tensor span is going to need to be moved in core lib so that the JIT can do inference on things like the length is never negative.
Does that answer your concern, Jared?
I mean, I'm just gonna talk to compiler team. We're gonna start looking at this later this week, so talk to them about it. Because I guess it's still like the system namespace. We still own it, and it's still a bunch of telling people. There's kind of two aspects to it. One aspect to the problem is that it's like, if people define their own system types, it's like, you're going to get what you get because it's a system namespace and we can special case it to our heart's content. It's the other problem is that sometimes when we start doing things like this, where we're like, okay, we're going to pretty somewhat deviously like start taking things like when the compiler and the runtime go into like sync on something, a lot of times we like to do things like look at core lib and say like, hey, we're going to lock on core lib so that there's no confusion on what we're doing. Because like I said, if we take the version, the proposal that was roughly done in language design, like we're going to ignore some of your implicit conversions because the compiler will just put them in kind of our tables so that we can then fit them into the precedences like we do for integers and floats and things like that. Like I said, that might be surprising to people, but that's how int works. Like we don't care what you write on int. We have our own conversion tables. You can do whatever you want. We're going to ignore them, which is the exact opposite of what the spec says we should do. But and so but it's also, there's some comfort in it when it's like, okay, it's in core lib, like, we know when we take these dependencies, we can move lockstep. When we're like, okay, we're going to do that, but for types that don't exist in core lib, it gets a little like, what happens, you'll get some strange weird behavior when you're moving between SDKs. And so it's probably not so bad in this case, but I just probably have to go home and think about it. And by home, I mean talk with Chuck and Alexei. It's not the end of the world.
I'm not sure how your wife and kid are going to feel about that statement.
Oh, it's my wife actually loves to hear about this stuff because it puts her straight to sleep.
Oh, you
She's
said
like, "Can you tell me about your job? Can you
when
tell me
you
about
said,
your job?"
go home, mean Chuck and Alexi.
Oh yeah, oh, God. That'd be a fun household. All right.
All right, so in index, I haven't heard a strong suggestion other than system buffers. I presume it'll be in core lib, but it can always be type forwarded down later if it's not.
I think it would, Tanner, the tensor work, that's the plan for that is still to be in a separate NuGet package, right?
The types are in a separate package, mainly because we wanted to polyfill on .NET 8. The plan
Right.
was eventually for them to be in Vox.
Right, but if they're in a separate NuGet, then an index would at a minimum also have to be there, and it could also be type forwarded down on net 9, but it would have to at a minimum be wherever tensor is, right?
Right, and we're already polyfilling index and range down level for net standard as well because enough people asked for it, if I remember right.
We are?
I thought we were. I thought that was one of the ones that got approved.
Yeah, aren't
but
they in
maybe
the
I'm misremembering.
in a
We've just
compat
discussed
package?
it too many times.
I can type today.
Yeah, I thought it was like Microsoft BCL index or something like that.
Emo says no.
Okay. Maybe it's just one of the ones that we've discussed time and time again and haven't done yet.
But yeah, that's a good point, Steve. If tensor's being in a NuGet package that has as a minimum TFM something older than 9, then in index will have to also be defined in a NuGet package. It doesn't mean that by 9 it doesn't live in core lib, but that will put it in the worst state of all types of basically we get it perfect the first time, because changing it after that is so hard that none of us can agree how to do it. Or at least the NuGet package would never get the updates. Okay, so system buffers, we add 2 index unchecked. Presumably that means we add to range unchecked.
Yeah.
We believe we have aligned on the name tensor span, but we didn't look at the shape of it at all. And I know we looked at the shape previously, but I don't know if it had any changes, and so I don't think we can approve it today.
Yeah, there was basically only one real change to it, which was the changing of the name lengths, because there was contention on that name to the name shape, because that's what it is. It's representing the shape of the tensor span, and correspondingly anywhere that took shape or that took lengths is now named shape as the parameter name. But that's effectively the only change that happened to it. There was a minor change to how the array constructor looked as well, to help clarify with the new naming. It specifically took a parameter named start for the multidimensional, and then shape and stride, so it's more consistent with all the other overloads that exist. But everything else is like we reviewed it last time, including the relevant updates from like adding the triflatten 2 API that we discussed should happen.
Right. I just remember we were short on people. It's part of why we couldn't talk about the name. So I don't remember if we made it through the type satisfactorily. So I'm not comfortable saying we're signing off on that today, which might mean it wants a new issue, so we can talk about what's approved versus not, or we just keep this whole thing together and give it another round of needs more meeting.
Yeah, I'd just keep it together because it needs to be approved all together anyways. There's no point in us exposing index and range without the rest of the types that are going to use it. So market needs work and API review. I'll immediately mark it back to ready for review, and we can take another 2-hour session to go through this.
Int 32 and int literals are implicitly convertible to inint, yes?
Yes.
So
which is why there's no overload taking int.
So in index idx equal 5 semicolon will compile. It will do some kind of conversion, whether it's intrinsic or user defined, while finding this implicit operator. Jared?
It only works because it's language defined.
Okay, so inint is a language defined cast.
What's the link?
I'm asking, will this compile with the shape that's currently on screen?
Which is just the implicit conversion from inint.
So, literal conversion of 5 to inint, and a user-defined conversion there, and then
no. There's an implicit language conversion to inint, and so therefore that should work. Array.length.
Because now that's not a literal. Will that work?
It's still, you can double up on implicit language conversions, and I believe so that should work.
So you can go through an implicit and a user defined, and that's together legal. Okay. If it's missing, we can add it later. I was just squaring off the shape and wanted to ask that question while we were still here. All right, so from start, from end match. In start is from end value match. Having constructors matches. We have the conversion from the existing index type and back to it, which is where we get these operators here. We don't undo this one with a name here because that's the function of the get offset function. So oh, sorry. It's the value property. Tanner says it does
so
work.
this
Clicky.
exactly
Clicky.
Yeah. So it exactly mirrors the shape of index, but with using inint and using with the implicit conversion from system index, the constructor that takes system index, and the API that converts it back to index. There's a language meeting in 3 weeks where we're going to double check that the implicit conversions are fine, and aren't going to block the language. If they would block for any reason, then we'd bring it back to API review, but I don't think they should block. We didn't have problems with other types that we did this, provided we were fine with saying there could be very subtle behavioral changes here if the language starts recognizing it as built in.
Okay. And then again, just squaring off range, all end start, the ability to build some, and end at, get offset and length, start at, and then undoing the conversion operations. All right, so I think we're done with in index and in range. And if there were a separate proposal, we'd call it approved. But we're going to keep this all together and call it needs work.
So is everyone happy, or?
I'm happy that we got through the first part of the proposal and got through the most contentious parts here, so we don't have to discuss it again.
My emotions on the
rest of the
subjects.
proposal should be.
I was gonna say my
Go ahead.
emotions span several dimensions.
Oh, Jared.
I expect the next part of the review should be less contentious because it's mostly just APIs following existing naming conventions and shapes.
Okay. We changed the names. We now have a pattern for explicit conversions and pairing them with named alternatives, which is the short name goes checked, and we add unchecked for the variant. We picked the name tensor span, though we'll see if there's an argument to unpick it next time. We picked in index, in range. We picked namespaces for them. We looked over the shape of those types. We hope to not look at them again. Did I miss anything?
That sounds right to me.
Okay. Obviously, I only updated the one line of tensor span, but who cares? All right. Leave blocking needs work. And after I have the review bot send out the email, I'll just change it back for you, Tanner. Since I'm the only
Thank
one
you very
with
much.
visibility on that. I mean, you could wait to see when you receive the mail, but... Alrighty. Yeah. So, thanks everyone who showed up on the call, since I was about 7 seconds from canceling the meeting when people showed up. And thanks everyone for joining us online. We had some really good feedback, even though it doesn't really feel like we made progress. It was the kind of monumental progress that takes a long time to get there. And we will be having, according to our calendar, a Thursday meeting this week. And I don't know what was up with there being 2 things on YouTube. I'll square that with Emo and we'll figure out what went wrong so we don't have confusion again on Thursday or beyond Thursday. So, with all that, it is lunchtime in Redmond. So, thanks all for being here, and we'll see you on Thursday at our same .NET time here on our same .NET channel. Auf Wiedersehen.